Good day, ASs. This is question number 7 of exercise 9C. It says that the center of a circle is at the point 4,8. You can see that on the diagram. And its radius is 3. Find the length of the tangents from the origin to the circle. In other words, we're looking for the length of these lines, which we know are equal. So the first thing we're going to do is we're going to draw in the radii. Now we'll draw them in such a way that they are 90 degrees to the center. In other words, the radius must make a perpendicular line. Let's do it here as well. Okay, so they are radii meeting at the center, and they are obviously 3 units in length. So we'll put a 3 there. Now we know that these lines are 90 degrees to each other. Okay, so one of the other lines I'm going to draw is this line over here, which is going to the center of the circle. Sorry. There we go. Right, so that line, we don't know its length as yet. The question is, if we could find its length, we'd know it's the hypotenuse of the 90-degree triangle that we have over here. And with that, we could actually find the length of the tangent because we know 90 degrees. So I'm just going to erase that last shape over there, but there we go. Okay, so that's what we're interested in, is that 90-degree or that Pythagorean triangle. Well, the question is, how can we find the length of this line that I've just drawn? Well, we do already know that the center is at 4,8, so that means that if I draw a line here, and there's quite a bit of construction going on here, you can see. Let's just draw that line in. It means that the length of that line is 8, and the length of this line is 4. Well, the reason being because that's the center point, and that's at 4,8. So it's 4 in the x direction and 8 in the y direction. Okay, there's 8, and here is 4, and so that length must be 4 over there, and this length must be 8 over here. So therefore we can go and find the length of that line, this line over here that I just drew earlier. And that's simply by Pythagoras. So 4 squared is 16, 8 squared is 64, 64 plus 16 is 82. Okay, sorry, 80. 64 plus 16, yeah, it's 80. Okay, so this must be the root of 80. Well, that's useful because now we can say that 80 minus 9, okay, in this triangle, using Pythagoras, 80, which is the square of the root of 80, minus the square of 3, which is 9, must equal this side over here, which is the side we're looking for. So this must simply be the root of 71. And there we go. That's how we do number 7. All right, let's look at number 8, which is a nice question as well. It says a circle touches the y-axis at the origin. Let's draw in our axes quickly. And here we go. And they said that the circle touches the origin. So let's draw a circle. Okay, one more time. There we go. and let's put that circle touching the origin. Now for it to touch the origin, it means that this must be a tangent to the origin, so it must sit just where it touches. They also told us that it goes through the point 80. So the point 80 is going to be over here. Okay, 80 is over here. And then they say there is a point C on the circumference. So somewhere along here where we could form a triangle. OAC. Now they want to know what would be the greatest area of that triangle. Well, clearly, since the base is fixed and we know that this base is from 0 to 8, so we know we have a base of 8 and we know the area of a triangle is a half base times height. So half of 8 times the height is 4 times the height. Well, what would the height be? Okay, so the height has to clearly be the point where it will be the furthest distance up here. Now that's going to happen when we get to the point where we get to the highest point of the circle over here. So this would be the height we'd be interested in. And since that must then be a height that runs through the center of the circle, it would have to be part of the radius, and we could know that we already know that this line over here must be a diameter, because this also is the furthest part of the circle, so it must be part of the circle that makes the diameter of the circle. That means that this height would have to be 4, and so that would make it 16. Okay, now that was a fairly easy question in terms of that, but I'm going to make it slightly harder. I want to know, what if we have the following? So this is an extra problem for you guys, especially those guys who like to think a little bit further. Let's just erase all this. What would be the area of the triangle? Same question, point C being anywhere on the circumference, if it did the following. So we're gonna say that it still goes through the point 0, 0, but this time it doesn't touch at that point. So in other words, it cuts at 0, the origin, and it also still cuts at 8, 0 over here. Okay, so 0 and 8, 0. And now again we're going to put a point C somewhere up here, and where would we get the greatest area, and what would that area be? Okay, so the last one was easy because it was a diameter and a radius, but this time it's just a chord, and it's not going to be the height. That's the best height, or the highest height for the triangle won't be the radius length, which was 4. So let's see if you can work that one out. It's quite a tricky problem. I'll do an answer to that at some stage, but have a try and see if you can get it. So that's question number 8. Right, then we get to question number 9. So let's have a look at number 9 quickly. This is a really fun problem. So let me just clear everything away here. There we go. And we're going to draw a nice... Actually, let me draw the circles first, because otherwise we might not be able to fit them all in. So let's get a whole lot of circles here. We need 6 of them. So I'm just going to copy this one 6 times and place all the circles in a picture. Right, so that's not too bad. Let's put 3 more. And we've got circle here, this circle here, and this circle here. Let's just move this one a little bit closer. There we go. So These are 6 circles arranged like some snooker balls. We're now going to draw the triangle around them. Okay, and let's use the ruler for this as well. So here we go. And down at the bottom here. Right, so there's our triangle. Okay, so the question says that a triangular frame is made to enclose 6 identical spheres as shown. Each sphere has a radius of 2. Find the length of the sides of the frame. So we want to know the length of the sides of the triangle. Okay, and we know that the circle's radii are 2 in length. Alright, so let's draw some shapes here because I want to show you a couple of things. So firstly, if I make, and I'm going to use a different color, a nice radius here, because remember the radius is always, you agree that that triangular frame will make tangents to the circle. So if I draw a radius at each circle, that is 90 degrees to that tangent. We know it is a radius because it forms a 90-degree line, so that length would be 2. But this length can also be 2 over here, another radius that then makes a tangent with the other sides of a circle. And I hope you're starting to see a little bit of something forming over here. Okay, so what we can say now is that this length over here is 4 because it's 2 radii, and that length is 4, so that's 2 radii. So that gives us at least some part of the side length. Now, if I do the following, and I'm going to do another radius here because it must form 90 degrees, and I'm going to do the same up here, must form 90 degrees. You see that it will make some more triangles over here. So let's see, if we keep doing this idea, we'll also have another 90 degree over here. Right. And we know that this is 2 over here. Excuse me. This is 2 over there. This is 2 over here. So the question is, what is this length over here? Well, the next thing I'm going to do is to draw another line over here. And you can see that again from our tangent theorem that we had before, these lines are equal, that line is shared, and these lines are both radii, so these are congruent triangles, which means that these 2 angles must be equal. We already know that these 2 angles over here, sorry, are 90 degrees because they are there we go, 90 degrees, because the radii make 90 degrees with the tangents. Okay, so we've got 2 and 2, but we don't know what any of those other sides are. Okay, but we do know that the angles are shared, and we've got the same triangles everywhere, so we can now safely assume that these must all be the same, and therefore this must be an equilateral triangle, 60, making this over here 30. Okay, so that means if we've got the side over here and we want the side over here, we can just use a tan ratio in a 30-degree triangle. Okay, so we've got y over x there. So let's work out what that one side is, the x side, which is the side we're looking for. And that's going to be inverse, or tan 30 is 2 over x. So therefore x is 2 over tan 30 if you rearrange. So 2 divided by quickly. Right, 2 divided by 30, 10 gives us 3.4. Okay, 3.4, 3.5. So let's just make this here 3.5, and that comes from trig. Okay, so that means this side over here must also be 3.5 because it's the same kind of triangle. And so we can add up all the lengths now, which are 3.5, 3.5, 4 and 4, which gives us 8 and 7, which is 15. Okay, give or take 1 or 2 decimal places. If I was using more accurate figures, but if I was just using one, it would actually round up exactly to that. Let's go and check that answer quickly, which is number 9 of 9C, and see what they say. Right, so exercise 9, chapter 9, number 9C, number 9. Okay, they gave an answer of 14.9 or 15. There we go. Okay, 14.9 or 15. So perfect. All right, I hope you've got that. So that's questions 7, 8 and 9. I'll do a couple more on the next video.